So I'm recording again. Okay, so now on to the next slide. So now, as I said before, we can learn a lot about a function from its graph. There is the concept of a function increasing, decreasing, or being constant. And it really depends on what happens to the output as the input increases. In other words, as we increase the input, if the output also gets bigger, also increases, we say the function is increasing. If instead, when the input gets bigger, the output gets smaller, then the function is decreasing. And in that case, the graph is actually going to fall. In other words, as you move horizontally to the right, to be increasing, the graph is going to go up. You climb, the graph is climbing. However, it's decreasing if the graph is falling. And you could be neither, in that you could be constant. Constant just means the function doesn't go up or down. It's just horizontal. And just to help illustrate it, I do have some examples here. So for instance, if you look at this function, right, hopefully you can see that as you move to the right horizontally, right, notice that your x values are getting bigger, right? You're moving to the right on along a number line, so your input gets bigger. And notice as we do that, this function is climbing, right? It's climbing. So because of that, this function is increasing. This function is increasing. Again, as you move to the right, you can see walking along the graph, right? You're going up. Your height is increasing. Whereas if you look at this one, as you walk to the right along the graph, here you can see the graph is falling. The graph is dropping. In other words, your y values are decreasing. So because of that, the graph is decreasing. So that's what happens here. Okay, so that's one. Those are two examples. Let's move on to, there we go. So if we go to here, here's another example, right? So if you look at this one, right? Well, again, is this going to be increasing or decreasing, right? Well, as you move to the right, so as you walk to the right, as in the direction of this arrow, what's the graph doing? Well, it's going up. It's climbing. It's climbing. You can imagine walking along the graph, right? Well, your height above the x-axis is increasing. Your height is increasing. Well, that tells you the function is increasing. So we have that example. Okay. So again, you just look at the height. What about this one? Now, what is this function doing? Can someone say it into the microphone? What is this doing? I can't see the chat, so if you can speak it, speak it.
Decreasing.
There you go. That's what I'm talking about. So it's decreasing. And how do we know that? Because as you walk to the right, what's happening? The height, the graph is falling. You can imagine walking along this graph, right? You would see that your height above, relative to the, the x-axis, is getting smaller. In other words, as you walk to the right, you're falling. Okay? So here we're decreasing. Now here's another one. Hope everyone can you see? What about this one? Well, notice that it starts out decreasing. See if I can get to it. This one starts out decreasing, right? You know, as you first walk to the right from here, right, you can see that you're falling. But then at 0, 0, at this point is actually called the origin. That's where the two axes intersect. We call that the origin, O-R-I-G-I-N. Once you get there, the graph makes a U-turn, and then it starts increasing. So it's possible you could start out decreasing and then change to increasing, you know, make a U-turn or whatever. That can happen. Okay? That can happen. So that one is actually starts out decreasing, then it's increasing. Or as a whole, I guess it's not really doing either because it's not falling throughout its whole. It's not falling through that. Can't speak. It's not falling the whole time or rising the whole time. So, all right. Anyway, let me just say this: we will get to linear functions, but a vertical line is not the graph of any function. You might have seen that before. I know if you had me for other classes like Math 104, I think some people have had me for 104. I did say that, but I did say this, that a vertical line, that's not the graph of any function. There's actually something going on in the background called a vertical line test. You might know it. If you don't, that's okay. So it's just something I wanted to point out. Okay. But anyway, now you'll probably know already what this is, but we'll get to that. We have what's called a special kind of function called a linear function. And that is a function whose graph is a straight line. That's not vertical. So a special kind of function we're dealing with is a linear function. That's just a function whose graph is not a vertical straight line. Or to be a little more precise, it's a function that looks like this. You have our function, f is linear if it's of this form. The m here, we call it a rate of change. I'll tell you why shortly. The b is the value of the function at 0. So it's f of 0. But this m is actually called two different things. It's a rate of change. It's also called the slope of the line. It's the slope. It's also called the rate of change. And this, I thought this would be not, oh, it's there. Okay, we'll get to that. But this m is the slope. It's called the rate of change. And the way you actually calculate it is using this formula. Namely, you take two different inputs, okay, x1 and x2. You know, you calculate the difference of the y values over corresponding x values. I think we may have to do some examples of that. But this is what the rate of change, also called the slope, is. So it's called two different things. I mean, that's what the book calls it. So it is the slope of the line. You know, that's what your m is, right? This is what I meant to say. You have two different points, different in their x values at least. And then you do change in y over change in x, corresponding change in x. That's what we have. Okay. That's what we have here. Good. All right. Okay. So that's what a linear function is. And this is something else I said also that I wanted to point out that, I mean, this is a little more general, and so I'm not sure if they covered this part in the book, but really any non-vertical line you draw in the plane, you can write in this form. Any non-vertical line that you draw in the plane, you can actually write in this form, where m is the slope of the line, non-vertical, so it has a slope, and you would use that formula from before, and b is over here. B is the value at 0. And this is something they do in Math 104. I figured I would put it over here. But you can actually, well, you can take this a step further and write an equation of a line this way. It's actually what they call the point-slope form. AC is just any point you want on the line. I mean, if you happen to choose AC to be this point, 0B, then you would get this. So this is a little bit more general. I mean, it turns out that any non-vertical line, to get an equation for it, you just need the slope at a point on that line. And then you can use this form to get an equation of that line. Okay, let me just get to the recording. We just stopped the recording.